it like
You don't
have
need-
to like match up the numbers?
These don't matter.
So
The only
you
information
have,
that's
like,
pertinent is right here.
one number.
This is the only.
So don't you get to choose the last number?
None of that is important. The only thing that's important is this.
Oh, got it. You have a 1 in 38 chance. Looks like your expected winnings on one ticket is $4.
So wait, what would X be?
Like your expected winnings.
Grab one of those when you come in, Lisa.
Wow, wow. What do you mean? No, you're expecting winnings to just be like the events.
So you can just do
Oh, perfect.
2.
Yeah. What did you speed what am I trying to say? What was it?
Oh, is it when you times the
Yeah.
prize by the probability and then you add them all up?
I think so, yeah.
I thought it was
What is it? You know, X is like
Oh yeah.
Let's
You know like a formula or something?
I know what it is.
Yeah, because you're just like.
Because you just multiply this by
and then add
everything.
Yeah, that's right.
Yeah.
How do you count for like? Okay.
If you add it,
So you multiply.
and then you
This odds and add them.
There's a special prize on that Powerball sheet, which isn't told to you, which you have to infer. So there's a special prize on there, and I wink at you when I'm saying special. All right. So it's a special prize on there that you'll win most of the time.
that will win. You get money.
There's a special prize that you'll win most of the time if you play the lotto.
It's -2.
Mm-hmm.
So you.
Oh.
So yeah, and then add -2.
Yeah, we'll just minus 2 from
Yeah. From whatever we get at the end.
Okay, so if we're doing
That's
that, the prize money comes to odds.
Someone do. I'm trying to pop it. I'm just trying to write it out.
Mm-hmm.
What is like the discolored ball?
That is the, I forget what they call it, like a special ball or something. Powerball?
This is what I did.
Yeah.
This is what I got when I multiplied and added all of them up. So 32 cents? 33 cents.
Really?
Less though, so it's one. You lose one.
Did you minus 2?
Not yet.
So
So you lose $1.67. Are we turning this bigger? Are we turning anything?
We are going to turn in something today, but not
Okay.
that. That one's just a do.
I didn't know if I was supposed to
what did
like
you get, Zach?
negative $1.06.
Okay. 1 out of 38, 1 out of 92.
-1.6.
I got negative 1.67.
1 out of 701.
That's like side.
1 out of 5. So there's a nice way to do this in your calculator with lists. This could be list 1, this could be list 2, this could be list 3. List 3 is equal to list 1 times list 2, right? Then you'll get all these values. At the end, you can just do sum list 3, and that will give you your expected value. So that's a nice calculator trick. Let's see here. 1 out of 580. 1 out of 14.
Do we do the probability?
That is, it's only one ticket.
know that we minus 2 each time.
That's just the expected.
Yeah, that's just one, two.
Like,
Like according to probability, the odds.
Okay, so let's find out. What number are you all coming to? Because I'm sure we have some different numbers here.
$1.66.
You got negative $1.66.
I got negative $1.67.
Anybody else?
Oh.
Anybody else? Did we all come to the same answer? Yes?
Yes.
All right. Let me just write this down then if we all came to the same answer. Well, actually, how did you find out the probability of winning negative $2?
It's just $2. You're definitely gonna lose $2.
Actually, I want to know how you calculated this because if you didn't calculate this right, everything else is wrong. This is 1 minus all of these probabilities. Did you have that step in your work?
Definitely no. Can you explain to me why that is?
Because if they're like,
Let's hear it.
you have to. I don't know how to explain this, but you can't like.
These are your only options.
Right. So you have to have a base option, which is
All the probabilities add to 1.
right.
I don't know this one,
Yes.
but I know that this plus this equals 1. Therefore, right, all these options, purple, plus probability of negative 2, right, all these probabilities plus probability of negative 2 must equal 1. So therefore, probability of negative 2 equals 1 minus purple.
Why is I don't understand why getting negative 2 is like a probability though,
Because
there's
That's part of the probability.
Yep. There's a very high probability that you're going to win negative dollars. So let's find out how to do this in our calculator. All right.
yeah, I don't understand because it doesn't seem like there's a probability of losing $2.
Oh, there is. You have a
Most of the time
It's
you're not
a
gonna
game.
win anything, so you spend $2 and don't.
But whatever you win, you're gonna have to minus $2 off the top.
And
So if
if
you
you
win
don't
zero,
win
then you get
anything,
negative
then you're in debt by $2.
Mm-hmm.
Right. So, but like I don't understand. There's like no probability in that. You're always 100% of the time gonna lose $2.
Right.
But it's
Well, you
saying
also
that there's
don't
a very
use
high
It's not a
probability.
percent. So you're trying to find what that percentage is.
You have a higher probability of losing $2 than winning $4 for
Mhm.
1 in 38.
Mm-hmm. So this is how we do this. Add up all those probabilities. And I think Stephanie and Maya, it sounds like you both already did this, right? 9, 1, 3, 1, 2, 9. If you add up all those probabilities, here's your probability of winning something. About 4%, right? So your probability of not winning, or sorry, losing money is 1 minus that. So losing $2 has a probability of 1 minus, let me do my answer here, 0.95957. So this is roughly 0.95957. All right. Does everybody see how you would set this up in your lists for your calculator? This would be list 1. This would be list 2. List 3, you would write equal to list 1 times list 2. Do we know how to do that? Yeah? Okay, then at the end, where's your sum button? Somebody tell me how to find the sum button so we all know how to do that. Because you need to do this, sum L3 to find your answer. This would give you your expected value. How do I find that button again?
Math
Math.
zero,
Math, that's what.
Math 0?
I mean, it says summation and then it has the sigma.
No, we don't want that. Isn't it probability?
Under math, oh yeah, it is.
Is it in
I think it should be. We should all have it on here. I can't find mine actually.
Pretty far down on math.
Under math?
If
But I-
you hit 0.
But that, mine says solver.
You don't want summation. You don't want the sigma.
Solver's B.
Oh, you do second stat, go over to math, and then it's the fifth one.
Oh, okay. Good. So I didn't have that in mine, summation, but this one is in there. If you go to second math,
Okay.
and
It looks different.
there's, not second math, second stat, right?
Yeah.
Second stat, go over to math and sum. So second stat, go over to math, and that's how you will find sum. Does that make sense? Yeah. This is a real quick way, for example, when you're allowed to use your calculator on that HL or SL test to find expected value. So be comfortable doing that. Are we good?
But then how do you account for the $2 that you spend for things? Yeah, but no, like, well, for like the 4s and like the 7s, don't you still have to subtract 2 from all of them?
Nope. So these are my outcomes. These are my possible outcomes for this random experiment. I can either lose $2. I can win 4, win 7, win 7, win 100, blah blah blah. These are all my outcomes.
So for those, it's like what you gain and not like what the actual prize was. It's like the actual prize theoretically is like $6 and then $8 and like 102.
Mm,
You put -2 in there, so that's why.
I'm just gonna say it.
so again,
None of this makes sense.
don't want to hear that. All right. Expected values, just take your outcomes, multiply them by the respective probabilities,
Yeah.
sum them all up, and then you have your expected winnings.
Yeah.
In this case, right, we had a -2 in there, which was our $2 originally spent, because we only played the game once. So therefore, we don't have anything else to account for. We've already taken care of our possible outcomes. We took care of our respective probabilities. We've summed them all up, and we get an outcome of negative, I forget what it was, 1.6 something.
Yeah, I was just thinking because, like even for like when you do win money,
Mhm.
don't you still have to subtract from like the initial costs of what it took to play?
Right, but I think you're talking about something different. I'm just saying, what are you expected to win? When you play this game, you are expected to win negative, on average in the long term, you're expected to win negative 1.66. So that's what this question is asking. What's your expected return from playing this game?
But then, see, the only reason like I did the -2 is because we like said that -2 is an option. So then it seems like you're counting the loss for like all of them. Because then it seems like you're taking like your total after you bought the ticket.
Mhm.
And if it just says that's the prize money, then like I thought you had to take the $2 out of the prize money. And I think that's what we're saying.
I see what you're all saying, but then you would be telling me that you would have won $2. I'm just saying this is a winning. You have a possible winning of $4. I'm not saying
It's not the net.
it's not the net exactly. The net would be $2. So you're talking about something separate. This is a possible winning. You could win 4, you could win 7, you could win 100. However much you break out to net, that's your own wallet. I don't care. This is just what you can win.
I don't care.
Does that make sense?
Yeah, that makes sense.
So again, expected value, don't complicate it. It's just possible outcomes times the respective probabilities, sum them all up, and you get what you're expected to win. Good with that? All right. So, I don't mean to be mean, but we have some extra, I'm not going to say the joke.
Mean
We have some more means to do. All right. So,
Oh, Mr. Russell,
we're
you're
going
not
to,
mean. You're just average.
thank you. Oh, I like that. So, we're going to start off with the mean. So let's get this down and then I'll have some more math jokes.
Ooh. That's true.
This one's important because it comes up a lot in probability. You're going to transform a random variable, and then you're going to be asked for certain calculations on that new variable. And so that's what this is going to be helpful for. So while you're writing, I'll just say what it says. Suppose you're given a random variable x, it's discrete, with probability function, well, you have it right there, and you're going to transform x by some function g. Well, then you can find the expected value of y by doing this, summing up the function times the respective probabilities. Right? So just evaluate each of the possible outcomes for x with your function g, multiply them by their original respective probabilities, and there you go. You sum those up, you have your expected value. So just to compare it to what we had done before, right? We had this, we transformed it by g, so the only thing that changes is now we don't have xi's, we have g of xi's. That's our function. Does that make sense? Okay. So, find expected value of the random variable x squared. So what's the transformation? Transformation is just square whatever the x value was before, right? The transformation y is just take whatever x was and square it. So now make a new column of x squares. 2 turns into 4, 5 turns into 25, 6 turns into 36, 12 turns into 144. And now let's find the expected value of y. Well, let's see. 4 times 1/7 is 4/7. 25 times 1/7, 25/7. 36 times 3, what's that? 30, 60, 90, plus 18. 108. 108 over 7. 144 times 2, 288 over 7. Let's see, adding all those up, somebody help me out with the math here. 12, so that's 400. Thank you. Yeah, 425.
Parker was about to help you.
All right, there we go. As long as I get some.
And I was writing it down.
425 divided by 7. Should double check me. And there you go. That's going to be your expected value for this new transformed random variable y. Does that make sense?
What is a transformed random variable?
Okay, so that's a good question. What was your original random variable? It was just x, right? All of your x's were
Squared.
okay, so the transformation was take your original x's and square them. You want to know the expected value of this new one? Just take your new x squareds and times them by their respective probabilities, sum them up, and there you go. Good?
What is that doing? Like finding the 425 or something?
I'm leaning to it. Well, what is it doing? First thing is you just found the expected value of y. So you just found a mean. Wait, a mean for a new transformed random variable.
So could we say that the random variable y is equal to x or the random value x squared?
This is y. Y is equal to x squared.
Okay.
Yes. This is something you need to copy down because it's going to be important.
That doesn't look complicated at all.
This says that the expected value is a linear operator. All right, so when you do this, well, let's see. Expected value of ax plus b, this comes up a lot. It's just going to turn into a times the expected value of x plus your constant b. So just have that down. It's going to be an important piece we're going to use later.
Should we write down all those steps, or should we just write down the steps?
Probably just, if you want to know why, you can write down the middle. But if you just want to know the answer, right, for the formula, write down those three.
That's your
I think Jaden would really appreciate you. Jaden would really appreciate you.
Well, I'm making a video, so
That's good.
we'll send them all a nice message. Good luck on your ACTs.
Hope you didn't fail your ACTs.
Now do all this.
Only a 36 in math acceptable.
Is it 36?
It's out of the
It's out of 36.
Oh, wow. All right, ready to go for it?
No.
No? Okay.
Now,
I guess if you want to, while they're copying this down, why does this one just turn into B? Why does this one just turn into B? What happens when you sum up all the probabilities? Turns to 1, right? So B times 1 is B. Okay? So it's important. Go for it.
I mean, if you're feeling like it.
Okay. This one's important. We haven't talked about this yet. Cumulative. Accumulating, right? Accumulating function. We've talked about that a little bit. This is a cumulative distribution function. Cumulative distribution functions sum the probabilities for each new outcome. So for example, let's say, what is our PDF? What are the respective probabilities for each of these x values? Because these are accumulations up top. Notice how they all sum to
Right.
1.
So wouldn't it be 0.12? How do we say numbers again?
So when x is equal to -2, what's its probability? 0.12. How did I go from 0.12 to 0.23?
You have to subtract that.
You're right. I added 0.11, right?
Right.
Okay, so that one must be worth 0.11, right?
Right.
How did I go from, let's see, 0.48
25.
from 0.23? I went up 0.25, right? So this is going backwards. How did I go from 0.48 to 0.76?
20.
Went up 28. 0.76 to 0.94. 18. And then finally, 0.06. So let's check our math, verify that those sum to 1.
What's the point of doing anything like that?
Cumulative distribution functions are so important, they even have their own acronym. All right.
What
So-
are they used for?
I thought you were going to stop that question earlier. What's the point of doing anything?
Well, yeah, we're not there yet talking about cumulative distribution functions, but it is important. For example, if I want to know what's the probability that you're going to die if you're driving a car, and look, let's say what's the probability you're going to die 100%? But let's say what's the probability you're going to die in a car accident under age 18 if you're driving? I can use the cumulative distribution function to just input one value instead of integrating all over all these values. And I can just say plug this into my function, and I'll get out the probability that you're going to die if you're driving less than 18.
Why is this on your mind? Are you like, we're good drivers. It'll be fine.
Well, it's a good pointer, right? Be careful when you're driving. Right? Okay, so now your job, we just did one step, calculate expected value of x.
How did you get to PDF? I was like,
Well, but I can't repeat it.
it was
Ask
like-
your
it was more
class.
like- it was more
Honesty
I
is
was
the best
copying-
policy.
Okay, well, it was more like I was copying everything.
Do you want me to tell you?
Talk to each other while you calculate expected value, okay?
So,
We've done that. So
I put the
basically all of
video-
these ones are adding up, right? So each time they're adding, so it means to find this one, we need to like subtract it.
so 23 minus 12.
Equals this one.
No, this one doesn't have this.
This one
And
doesn't.
then 40
This is yeah, it's already.
like 6 times like 1 of its points.
Oh.
How would you like that question?
So you guys should be calculating. This isn't working out for me.
It's peach
Sorry.
fuzz.
Sorry, I was. Going to move now. Stop
Wow.
No, Jeff, you did.
What?
Let's change that.
Alright, expound two is.
We need to do our work.
Kane, stop distracting us.
See you, Cam. Okay, so what'd you get? Me too. Okay, so your expected value, if you did these calculations, you should have got,
and 11 100s.
there you go, 2 and 11 100ths. Alright, so that's important, alright, CDFs, we'll probably talk about a little bit, but I know this might pop up, for example, on your HL or SL exam. It might give you the CDF and ask you to calculate something like the expected value. Good to go on? Any questions? Okay. Variance. That's something else we got to talk about in statistics. Variance is the most important and common measure of spread. All it is the expected squared deviation from the mean. Sounds simple. Let's get this down.
Avery,
I was
Oh,
doing,
yes.
I was doing math.
you counted the number of people in the room.
I counted it wrong. See, it's
Variance is a measure of spread. It's the most commonly used one. It's the expected squared deviation from the mean. And you can see that right here. So again, times the probability because it's the expected. So it's what you're expecting. So take the probabilities, times them by the squared deviation from the mean, and you'll get the variance. That's a very long way of calculating the variance, and I'll show you a short way here in a second. Well, calculator, but sometimes you're not going to be able to use it, right? So on some of these exams. And on the P exam, if you ever go into actuarial science, you have to take the P exam, and you won't be able to use your calculator to do something like this. You have to use the easier method, which is down below, which I'll show you in a second. No, I've taken that one, but no, I'm teaching. I chose the
I don't know
glorious
if you
route.
noticed, but he's teaching.
No, I'm teaching.
Okay, so are we all good with what this variance is? You sum up all the squared differences from the means and times by their respective probabilities. So it's the expected squared deviation from the mean, right?
Should you have two different sets of data? Or is it just one?
Nope, all of these are your xi's. You already found the expected value. This is the expected
easy.
value,
Okay.
right? Here's your xi's, here are your probabilities, here's your expected value. Well, it's a lot easier to do if you know how to transform a random variable. Variance is, right, expectation of x squared minus the squared expectation of x. It's a lot easier to calculate sometimes.
What? You just wink at us?
Yes, I did this. Variance is expectation of x squared minus the squared expectation of x. Sounds like a lot.
You have to sound a lot easier.
Do you want to see why? Yeah?
Yeah.
All right, there we go. I like it.
Why do you have to use that?
We'll show why in a second here.
Wait, do we need the rest of that, like, the summation?
No, you can cross that out if you don't want it, but you do need to know this.
Actually,
So why? Well, expand the binomial in there. Expand the binomial. So if you expand this, this is the expected value of
But that's different than what you wrote.
random variable squared. How many of those minus x times mu of x's am I going to have? If you expand this, you're going to have what? Minus 2 x mu x plus
Mu x squared.
mu of x squared. Okay, well, expected value, you can break these up into different pieces. So what this is, let's see, expected value of x squared minus 2 times, oops, 2 mu. This comes from the piece that we just learned on the other page that we can pull these out, times expected value of x plus expected value of mu of x squared. Okay, let's see, where was I going with this? Expected value of mu of x squared. How are we going to get to what we wanted? Trying to get to here, we have this,
Don't say that out loud.
This is a constant, but how are we gonna,
You can do it. Wink at it.
no, this is a constant, but I'm just trying to see how these are gonna combine, because this needs to turn into this. This is a constant, and it's squared. Alright. I'll put it online, but I don't see it right now. But here's this. You have the e of x squared right here. Somehow this is going to turn into this. I'm just not seeing it right now. So I apologize for that.
Could you factor out a
Hmm?
Is mu x the expected value of x?
Mu of x is the expected value of x. Yes.
So that is
Oh, you're right. Expected value of this, well, expected value of mu of x is just mu of x squared, right? Because expected value of x was just mu of x. Well, so it's going to stay the same, but it's squared. So it's that. But then how do we get rid of this?
Isn't it?
well, mu of x is expected value.
So is it just cancel out?
So
These two?
Yeah.
Oh yeah, this would cancel.
No, I'm sorry.
I actually have no idea. I was just saying things that sometimes lead us to like figuring it out.
That's good. I like the participation. And I'm sorry I didn't have the answer for us right there.
It's okay.
Okay, so practice, let's do the variance on this one. Let's calculate the mean and the variance of the random variable x for this distribution. All right?
Of the pizza.
Yeah.
Oh, pizza.
So this is about pizza, all right? Here's our probability distribution. Let's calculate mean and variance. There's two ways you can do it. You can do x squareds and then do mean of x squared minus mean of x squared. Or you can use the variance formula. It's up to you. I think I'm going to choose this route. I think this route would be easier, so that's what I'm going to do. Let's see, what does that add up to?
Gosh, you need 1 second. Literally 1 second.
Alright, nice. Thank you.
29.7.
Or how about, I wanted it as a fraction.
Oh, I got you. Give me just 1 second. 208 over 7.
208? Okay, so the expected value of x squared, that random variable, is 208 over 7.
Do you also need the expected value?
We do.
of x?
We also need the expected value of x. And we're going to square that at the end. For this one? So let's see, that's what, 6/7? I'm just going to write it all down. 6/7 plus 4/7 plus 6/7 plus 7/7 plus 12/7. Let's see, 10, 16, 23, 35, 35 divided by 7. Did you get 5?
Yeah.
Yep, 5. Okay, so put it together. You have expected value of x and expected value of x squared. So what's the variance going to be? Because we already took care of the mean. Variance is what minus what?
Oh, it's the expected value of x squared minus the expected value of x squared.
There you go. Okay, so somebody tell me what's 208 squared?
Wait.
We don't need 208 squared.
Oh, sorry, you're right. 208 over
You're
7?
testing us. Nice job testing.
I was just testing you. Minus 25, so what's
33
that?
sevenths.
33/7? You see how easy that calculation is?
That was so easy.
Right?
Tough. Can't wait for it to get way harder.
No, I mean, both will lead you to the same answer. So when you can, use the easier route. Any questions on calculating variance? Okay.
A lot of words.
Let's see. What are we doing for this one? Okay. Let's see. Remember our problem with we wanted 3 girls in a family? What, 0, 1, 2, or 3?
Does sound like a problem.
Okay, guys, running out of time and I want to get through this. Remember that random variable is from yesterday. I want you to tell me what is the expected value, the variance, and the standard deviation for this transformed random variable, b. All right, so you need to go back and say, what was that original one? So can somebody pull up their notes from yesterday and tell me what the original one was?
The original, like the data set?
Yeah.
Oh, okay. It was 0, 1, 2, 3, and then it was 1/8, 3/8, 3/8, 1/8.
Okay. Good, so we have that. There's your G. Now you're going to calculate B. B is equal to 2G minus 1.
So negative 1.
So let's see, yep. Negative 1.
1.
1.
3.
3.
5.
There you go. All right.
Good math.
So look at that. You got your B values. You have your probability for each respective B value. All right. So now you can easily find what's the expected value of B, what's the variance of B, what's the standard deviation of B. And if you recall, what's standard deviation? Standard deviation is just variance, square root of variance, right? You guys remember that?
What's the Greek letter that is variance?
Mu squared is going to be variance, and sigma squared is variance. Sigma, taking the square root of it, is standard deviation. So this one would be variance. This one would be standard deviation. So you guys calculate that. I think we got enough time to do that.
Sigma.
Sigma. Right?
Here we do.
Let's see. I would use lists in your calculator. List. Go to stat and hit edit. Go to stat and hit edit. Let's see. We want expected value, so I'm going to do that in my third list. Does everybody know how to make a rule for list 3? So you can easily calculate. I call this one L1. I call this one L2. So if you go to the top of your list, all right, if you click on L3, you can make a rule and you can call it L1 times L2.
How do I click on it?
Enter. So you can make a rule that says L1 times L2. L1 times L2 is going to give us what? X times P of X. So if I wanted my mean, all I have to do is sum all those up. So we, like Parker said, we go to stat, second stat, math, sum up. I'm going to sum up L3. Did anybody calculate the mean yet?
So wait, can you do that on your calculator though, where it's like L1, L2 equals L3?
You can. You can set up L3 is equal to L1 times L2. Did anybody calculate the mean yet?
L1 and L2 are second.
You got 2? Got 2, very good.
Sum is second stat.
So you filled all of this in on your calculator.
0.5?
Nope. If you summed them all up,
You have to go up like above that line. It's like where it says L3, you have to go and count that.
2. Isn't that pretty cool?
That's so cool.
When you find what the sum of L3 is, which is your x times p of x, you should get, sum them all up, you should get 2, so that's your expected value. Now, I want variance, so I should go back to my list, and I should make another row, or another column for what? I heard it?
Squared.
X squared, right? So go back to your, make another one, L4. I'm going to do it over here. L4, and that's going to be x squared. So let's see, negative 1
Is it b squared?
Huh?
Is it b squared?
Yes, we're talking about b. Yep, so you're going to square all these b values. Negative 1 squared is 1. 1 squared is 1. 3 squared is 9. 5 squared, 25. And then let's calculate our variance once we get out of that. So let's see, I need to do L1 squared as my rule. 11925, yep. Is everybody able to make that rule? Okay. Now let's see, I want an expected value of this one, so I need to make, guess what? Another column, right? Row 4 times respective probabilities, which are right here, right? So make another column. Whatever this row is, x squared times the respective probabilities. So for me, that's list 4 times list 2. Am I losing anybody? No? Bless you. I think I'm gonna be with you in 1 second. Let me check. When I sum up L5, what do I get?
is L5? You just the squared.
I got 7 too. Yep. 7. What did you put as L5? Well, I needed L4, which was x squared, times their respective probabilities. So mine was L4 times L2, because that was x squared times the respective probabilities. If you sum them all up, you should have got, let's see, 7. So expected value of x squared is equal to 7. Expected value of x, when you square it, well, what was the expected value of x? 2. When you square that is 4. So therefore, variance of b is equal to this minus this, 7 minus 4. 7 minus 4 equals 3. Variance is that. Standard deviation of b. Take the square root of 3, right? That's what your answer is. So are you good with variance? Are you good with variance of a transform variable, random variable? Okay. Are you good with standard deviation? And how about mean? Easy peasy, right? All right. Well, don't forget to do your homework, which is due tomorrow, right? There's a few questions on there. And it's only like 8 questions, so it's not too bad. It's all in score.
Mr. Russell,
Mm-hmm.
is the thing that says homework quiz the homework?
Yes, so that's the homework. I'm going to hand out a problem sheet tomorrow, though, for extra practice.
Mr. Russell, I forgot to give you the the practice ones that we did in class, or the one where you wanted us to self-grade. Did you still want us to do that?
Don't worry about that. Not enough people were. I'll just be more strict next time. I'll say it is due, and if you don't turn it in, you get a 0.
Okay. I feel like they weren't very happy with me about it. Accidentally being like,
Along with the Wii Shock.
Yeah, people were kind of upset about that.
That's how I used
Yeah, 2 customers.
shut up! Did anyone ever watch Netflix on the DS?
That's a thing.
to. Dude, I have a
I used to watch movies like on the big TV. Now I can't.
What did you do?
Watch Netflix.
You can't watch it.
You gotta
No, I watched Netflix on my 3DS, bro.
That's so bad.
They might have turned off the bell.
Dude, I guess that's one thing. It was like, it's like, yes.
Have a nice day.
Thanks, Mr. Russell.
Yep, have a good day, Jack.
Yeah, I'll see you tomorrow.
See you, Avery. Have a good day.
I don't. I bring you $1. Oh. Buddy?
Well, you're kind of cooked on this one.
So you're taking the HL test, right, Maya? Yeah. Are you ready for it?
Not really, but my logic was really hard. It's just most schools, if they accept any credit, it's usually from HL tests. So I took SL last year, and I did decent, but won't give me anything for that.
So the SL is just kind of like, it's good practice, but it's not going to count.
Yeah.
Well, we'll get a good practice in here for about like half a month before you take it, so hopefully you'll be all
Yeah.
good.
All right.
Yep. Have a good day.
don't know why it's not on the same. But yeah, there's 23 in the smallest, and then 22.
Hey.
Who want to be in here today? I'm either gonna have one student or no students.
Wow, that's it.